This is Dr. S. Lakshmi, Professor and Head Department of ECE from Rohini College of Engineering and Technology, Kanyakumari District. So, in this lecture, we will see about the another access technology, which is IEEE 802.15, 4.4G and E4E. On completion, the student will be able to define this access technology. They'll be able to describe the layers. They'll be able to describe or explain the topology and security associated with it. So here, what is this IEEE 802.15.4e? So this is the enhancement of the IEEE 802.15.4 MAC layer capabilities in the areas of frame format, security, determinism mechanism, frequency hopping, reliability, unbounded latency, and multipath fading. So, in the earlier case, we have seen in 802.15.4 the multipath fading. We have seen about what is the drawback, that is multipath fading and unbounded latency. So, this is overcome here in this particular technology. And this improves to better cope with certain application domains such as factory and process automation and smart grid. And here coming to the next associated technology, which is 0.4G, which seeks to optimize large outdoor wireless mesh networks for field area networks, that is fans. New physical definitions are introduced as well as some MAC modifications needed to support their implementation. This focus of mainly on smart grid, smart utility network communication is also used in IoT applications like distribution automation and industrial supervisory control and data acquisition. So, which is shortly or very familiarly called as SCADA environments for remote monitoring and control. Public lighting, environment wireless sensors in smart cities, electric vehicle charging stations, smart parking meters, and coming to the layers, first as usual we'll see two layers are there, physical layer and the MAC layer. So in the 4G, the payload size of 127 bytes was increased for the it is to 2047 bytes. This provides a better match for the greater packet sizes found in many upper layer protocols. The error protection was improved by evolving the CRC, cyclic redundancy check, from 16 to 32 bits. So data must be modulated onto the frequency using at least one of the following mechanisms. So that is MRFSK, that is multi-rate and multi-regional frequency shift keying. Then MROFDM, that is orthogonal frequency division multiplexing. QPSK, which is quadrature phase shift keying, which is all multi-rate and multi-regional. So enhanced data rates and a greater number of channels for channel hopping are available depending upon the frequency bands and modulation. So coming to the MAC layer, so these are the main enhancements to the MAC layer. The first one is time slotted channel hopping, that is TSCH, which divides the time into fixed time periods or time slots. So which offer guaranteed bandwidth and predictable latency. So once the time slot is allotted, so you will know what will be the time taken. So that latency is predictable. In a time slot, one packet and its acknowledgement can be transmitted, increasing network capacity because multiple nodes can communicate in the same time slot using different channels. So a number of time slots are defined as a slot frame which is regularly repeated to provide guaranteed access. The transmitter and receiver will agree on the channels and the timing for switching between channels through the combination of a global time slot counter and a global channel hopping sequence list as computed on each node to determine the channel of each time slot. So here I think you can understand this particular point where the timing for switching between the channels, it is set with a global counter as well as channel hopping sequence list. So this adds robustness in noisy environments and smoother coexistence with other wireless technologies. And the second one is information elements. So this allows for the exchange of information at the MAC layer in an extensible manner, either as header IEs, which is standardized, or payloads IEs, which is private. So it is specified in a tag length value, that is TLV format. The IE field allows frames to carry additional metadata to support MAC layer services. And the third one is enhanced beacons. So beckons to allow the construction of application specific backend content. This is accomplished by including relevant IEs in the EB frames. Some IEs that may be found in EBs, that is enhanced beacons, include network matrix, frequency hopping, broadcast schedule, and pan information version. And next one is enhanced beacon request, EBRs. It is shortly called as an EBRs. So here the IEs in EBRs allow the sender to selectively specify the request of information. So the responses are then limited to what was requested in the EBR. For example, a device can query for a PAN that is allowing new devices to join, or a PAN that supports a certain set of MAC or physical capabilities. And the next is enhanced acknowledgement. So this allows for the integration of a frame counter for the frame being acknowledged. This feature helps protect against certain attacks that occur when acknowledgement frames are spoofed. So suppose some acknowledgement frames are duplicate or spoof, then this feature will help or protect against these attacks. So whatever it has been explained, that is put up in the frame over here. So coming to the MAC layer, so this supports payload up to 2047 bytes and 8, whereas in 802.15.4 it supported only 127 bytes. And similarly, the auxiliary security header provides for the encryption of data frame. So this is optionally supported in both the cases. IE field contains one or more information elements that allow for additional information to be exchanged at the MAC layer. So any additional information you need to exchange, then that can be done at the MAC layer. So coming to the topology aspect, so this follows a mesh topology. So this is because the best choice for use cases, that is for the case studies in the industrial and smart cities, where this particular 802.15.4G 2012 version is applied. A mesh topology allows deployments to be done in urban and rural areas, expanding the distance between nodes that can relay the traffic of other nodes. So coming to the security, so this is actually the frame associated with the security. So we'll see about this. So the full frame in this figure gets authenticated through the MIC at the end of the frame. So even in the previous case we have seen MIC. There is a unique value that is calculated based on the frame content. The security header, it is again composed of auxiliary security field and one or more information element fields, that is IE field. Integration of the element field allows for the adoption of additional security capabilities such as key management protocol specification. So key management protocol is nothing but it provides a means for establishing the keys for robust datagram security. Without this key management support, weak keys are often the result, leaving the security system open to attack. So KMP is utilized over here. And these are the possible assessment questions. So you will be able to define what is this particular access technology, describe the layers of this technology, topology and security associated. You can also find out what is MIC. Thank you.